Let's work on applying the definitions from the last part of the lesson. We're going to first classify categorical or quantitative. And remember that categorical is another word for qualitative, quality. So if you see the word qualitative instead of categorical, those words are interchangeable. The heights of members of a soccer team. If you were to collect the heights of the members of a soccer team, would you be collecting categorical data or quantitative data? Heights are usually measured in inches or centimeters or meters or feet. So this would be quantitative data. Flavors of ice cream at a local ice cream parlor. Categorical or qualitative. We're not collecting numbers, we're collecting flavors. So we have categories. The jersey numbers of a women's basketball team. What do you think? Quantitative representing a count or a measure, or categorical, being able to put them into groups? Does the jersey number represent a count or a measure? That's the question you have to ask if you're trying to determine if it's quantitative. Does the number represent a count or a measure, or is it just a label? For jersey numbers in any sport, those numbers are actually just labels, not counts or measures. We don't often have all the numbers from 0 to however many players we have on a team. Sometimes those numbers, depending on if they're a single digit or a double digit or a high double digit, could indicate the positions that they play. So here, the jersey numbers, even though they're numbers, they don't represent a count or a measure. This is a categorical data. Okay, let's keep going. Is the data categorical or quantitative? If it's quantitative, is it discrete or continuous? Remember, only quantitative variables can be separated into discrete and continuous. Discrete meaning counts, continuous meaning measures. Hair color, is that a number or a category? It's a category. The number of students with red hair, if that's the data we're collecting, let's say we're collecting it from each class, this would be quantitative data. Since it's quantitative, we have to determine, is this discrete or continuous? Does it represent a count? Are we counting something? Or is it a measure? Are we measuring something? By measure, I mean we're measuring it with some other kind of tool, like a ruler, a measuring tape, a measuring cup, a scale, something like that. Number of students, we're counting. This is discrete. How about height? Height is a measure. We would consider that quantitative. And since we are measuring it, it is continuous. The weight of a bag of candy, this would be considered quantitative as well. And weights are measures, so this is continuous. We can have partial ounces or partial pounds in our weight. All right, let's look at boundaries. So we talked about boundaries in the last one as being all the numbers that would round to the given number. We're looking at this number 15. And I want to know, what are all the numbers that would round to 15? Well, 14.5 would round to 15. All the way up to 15.499999, which would be 15.5. And remember, we include the 14.5, but we don't include the last one, the 15.5. These would be the boundaries for 15. And so the idea here is 14, 15, 16. The boundaries fall exactly between these different numbers. So if we were to have a number line, 14, 15, 16, the 14.5 to 15.5 are considered the boundaries of the number 15. A couple of things to notice about the boundaries. I have one more decimal place in my boundary than I do in my given number. So my given number is 15, but my boundaries have one more decimal place. Also, my boundaries end in 5, both of them. You're going to see that every single time we write boundaries for these numbers. So let's look at 86. So for 86 degrees Fahrenheit, the smallest number that's going to round up to 86 would be 85.5. And then just like when we did 15, 86.5 would be the very beginning of the next group that would round to 87 degrees. And we need some units on here, centimeters for the first one, degrees Fahrenheit for the next one. Let's look at time, 0.43 second. Our boundary, we want to go just below that 4.3 to 0.425. One more decimal place than what's given, ending in a 5. And then our last number in the boundary, 0.435. So changing my number line down here, I would have the numbers 0.42, 0.43, 0.44, and then in between them, halfway between 0.42 and 0.43 is 0.425. Halfway between 0.43 and 0.44 is 0.435. Let's put our units on there, seconds. And this is how we would get our boundary. One more decimal place than what's given. Notice the digit that matches my given problem, my given number. I have one below, 4.2 ends in 5. And then here, 4.3 ends in 5. So I have one below and then the same in that same place. They end in 5, one more decimal place. Okay, let's try the last one. 1.6 grams. Write down what you think the boundaries are. See if you can catch the pattern. Notice how all of these last boundaries had the same numbers, just ending in a 5. So 1.65 would be the upper boundary for 1.6 grams. And then we need to go below that to the first number that would round up to 1.6 would be 1.55. We are going to practice this some more in Chapter 2. When we talk about graphing, we'll need these boundaries. But it's good to start practicing them now and begin wrapping our heads around this idea of rounding and of finding boundaries.